this moment. So just remember this. For the interference, we have two kinds, constructive and destructive interference. In terms of light waves, constructive refers to, take a look here. Here are the fringes, okay, the interference fringes. So we can have bright fringes or we can have dark fringes, just like we saw in the video. Okay, the pattern that we saw in the video is this one that you see right here, but this is just a diagram, but it represents the same thing. So the light, you see that the light is brighter in the center. Okay, you can see the opening is bigger in the center than the opening in the well, in the external part. Okay, so you can see this opening is bigger. I don't know if you notice it, but it's bigger. It looks bigger, and this is exactly what happens in the video. Okay, you see, like in the center of the viewing screen, you see all the fringes. Okay, and as long as you move to the exterior zone, then the fringes look far from each other, and that is very common for it to happen. The reason is because of this topic, the interference. Remember that the light is going to pass through the two slits, and then the waves basically, like, they collide and they form a pattern. Okay, they form a pattern, which is this one that you see right here. Now, from this double slit experiment, we can tell that the waves have an angle of interference, okay, which is this angle that you see right here. The pattern that it forms in the viewing screen can be measured by the orders. The orders stand for the letter M, okay, and the center of it is the order 0, which is right in the center of it, as you can see. Now, in the viewing screen, you're going to have two kinds of fringes. You will have bright fringes and dark fringes. So, I don't know if you remember, but in the video, it was mentioned. How do you identify constructive interference? By seeing dark fringes or bright fringes? Do you remember? Basically, this is what we watch in the video, okay? Basically, this is what we watch in the video, okay? So, the bright side represents constructive or destructive interference. Do you remember? Wow.
The one that is bright has construct.
Exactly. The one that is bright has or represent constructive interference. Okay? And the dark spots represent destructive interference, because there in the dark spots the wave, it's been like reduced, and that's why we see no light. Okay, so destructive interference, we see no light, is dark, and when we see light we have constructive interference. So here is constructive, and in between you have destructive interference. That's very important because that will define what equation we're going to be using. So take a look to the example that I will sketch. Take a look right here. Take a look right here. Okay. So we are here in this part. And let's say that this is my light source. Okay? This is a light bulb. Imagine that this is like a light bulb. Okay? So this is my light source. So what is going to happen? My light is going to pass through the slits, and it's going to create the pattern that we saw in the video. That is this pattern right here. But we cannot draw this. Okay, that will be weird to draw. But we can use this as a reference. Take a look. What you see right here is exactly what you see in the picture or what we saw in the video. The bright side represents constructive interference. Take a look. Constructive. And the dark spot, it's in between. Here, also here. That's my cat bothering. No. Okay, in the dark spot, you're not seeing it because I'm using a different sketch. Okay, the dark spots right here are what we know as the destructive interference. So this is how you recognize the two kinds of interference that are going to be involved in this kind of examples. Now, we can represent this how? Like this. Okay, I'm going to use a orange for the bright zones and black, of course, for the dark zones. Okay, remember, bright is constructive and dark is destructive. So the pattern that is going to be visible in the viewing screen is going to be something like this. It's going to be something like that. This one should be a little bit, yeah. Well, it should look something like this, more or less, okay? Doesn't need to be perfect. Okay, in the dark ranges, well, more or less, this looks like tigers and unicorns. I'm sorry if I'm too old to give you this kind of reference. You were raised by watching Pocoyo, right? So you probably don't understand about Winnie Pooh and that kind of things. Okay, that looks like tiger. Sorry about the choice, my choice. But just remember this. The dark zones represent destructive and the bright zones represent constructive. Okay? Cons, 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 this. Okay? Just remember that. Now, okay. What happens here is this is the prior sketch that you do. In the center, you have what we know as the principal axis. Okay? The principal axis is what we know as the order 0. What you have right here is what we know as the viewing screen. Ariel, no. I know, my cat. So embarrassing. Such a stalker cat. Okay, so remember that this pattern shows itself more or less like this. Okay, this pattern repeats and repeats over and over and until you see nothing. Okay, until the dark fringe is so big that you don't see more bright fringes anymore. Okay, so what is going to happen? This is a pattern that you must follow in this kind of exercises. So this is the same as I have here. The only thing that I didn't include is the light source, but just remember the light source comes from the other side of the slit panel. Now let's read the problem. It says the distance between the two slits is 0.03 millimeters. The second order bright fringe, or m equals 2, is measured on a viewing screen at an angle of 2.15 from the central maximum. Determine the wavelength of the light. So, this exercise is not telling me what kind of interference that I have. Okay, it's not telling me you have a constructive interference or you have a destructive interference. So you have to tell whether it is constructive or destructive. Remember, bright zones, bright fringes is constructive. Dark zones, dark fringes represent destructive interference. So because this exercise is telling me that the second order is measured for the bright fringe, okay, for the bright fringe. Because it's the bright fringe, we say that it's going to be constructive. Remember, bright is constructive. Okay, so that means, in other words, that we're going to be using this equation for this exercise. Sorry. So what is this exercise giving me? It says the distance between the two slits is 0.03 millimeters. So distance, when we talk about distance, we're going to be using the letter D to denote distance. Okay? When it says second order, refers to the letter M. M equals 2. Okay? This M from the equation. Okay? This M from the equation. So M refers to the order. So when you read about order, we talk about M. And then it says that M is measured on a viewing screen at an angle of 2.15 degrees. So the angle is the other data that we can obtain from the word problem. And then it says determine the wavelength of the light. So I need to find the wavelength. So all I do is I can sketch the problem like I did here, or you can use this general sketch to draw it. So I put my light source right here, and I will find the second bright fringe measured from the center. So the center is my fringe 0. The first bright fringe is this one, okay? And the second bright fringe is this one. So basically what the problem is giving me is the angle between my center, my principal axis, and the second order maxima. Okay, the maxima shows the bright zone. Okay, so this angle in this problem is 2.15 degrees, and it can either be positive if it is above the principal axis, or it can be negative if it's below the principal axis. That's why in the equation that we have here, you can see the two signs. It can either be positive or negative, okay, because of that reason. Now, because it can be positive and negative, we're going to have the angle in the two sides of the principal axis. And now all we do is we start working on the problem. So the sketch is going to be your step 0, okay? Sketch, the problem is the step 0. The first step, after the step 0, we go to the first step. If you read the problem, it's giving you the distance in millimeters, okay? So, the first step for this exercise will be to convert from millimeters to meters, okay? Remember that we always work in meters. So that is going to be the first step. So D, which is 0.03 millimeters, we're going to convert it to meters. So we're going to multiply times the conversion factor. That says that in 1 meter you have 1000 millimeters. Okay, this allows you to cancel m with m. This gives you how much? How much is this?
Is 0.0003.
Okay, and in scientific notation, this is 3 times 10 to the to a negative fifth power meters, okay, or 0.00003. Both are correct, but I prefer that for this kind of problems we use scientific notation. But that's my personal choice, okay? In the end, it doesn't really matter. Now, once you have all this, we need to use the equation because it's about bright fringe. We will be using the constructive interference equation. Remember, it is bright fringe. So this is the equation that we're going to be using. We will isolate for the wavelength, which is what the problem is actually asking you to find. So the equation already isolated for wavelength is this one. And as you notice, I didn't include the plus and minus sign. Okay, so for this kind of exercises, you don't need to include the plus minus, because wavelength refers to how open or how tight a wave is. Remember what wavelength is. A wavelength is a distance, okay? And this distance will be always a positive number. Okay, I cannot say that this distance is negative 0.5 meters, for example. No, it's just 0.5 meters. So, to find the wavelength, you really don't need to include the sign, okay? So, right now, all we need to do is replace by the givens. Okay, and we say wavelength is equal to 3 times 10 to the negative 5th power meters, sine of the angle, which is 2.15 degrees, divided by m is the second order, so m is just 2. How much is this? How much is this?
(3.2 times 10 to the negative 5 power).
3? Your calculator comes like this. 3 exponential negative 5
6 times 10 to the negative 7.
in your calculator. It must be like this. This is what I got. Okay, so check that your answer must fit. 5.63 rounded times 10 to the negative 7th power. The only unit that is involved is meter, so that will be the final answer. Now, the problem changes a little bit in this case. Take a look. It says it's almost the same problem. Okay? It's almost the same problem, but it says dark fringe instead of bright fringe. Okay? So that's the only difference in this exercise. So, because it says dark fringe, the equation that we will be using is going to be the second one. Okay? It's going to be the second one. Now, let's take a look. For the second one, okay, the situation here is the same. Okay? So the step 0 is going to be the exact same, so I'm just going to copy and paste. Also, the first step is going to, the sketch is the same. It's not going to change because it's the same situation. The first step is also not going to change because it's the same data. Okay, so you will have to do the same conversion process. It's going to be the same conversion process as the first step. But the second step changes because now we have dark fringe instead of bright fringe. Okay, so the second step, sorry for moving this so often. So in the second step here, the equation changes because we have dark, not bright. We have dark interference, destructive dark interference. So the equation that we must use is the one that is in the second part, which is the sine of the angle equals plus minus and whatever. Okay, I'm just going to write it and isolate. Okay, that is the equation. But then all we do is we isolate for wavelengths, since the problem is asking me about wavelengths. So wavelengths is going to be equal to the sine of the angle divided by m plus 0.5. As I said before, we really don't need to put the plus and minus to find the wavelength. So all we do is we substitute by the givens. We still have the same angle. And we divide by m plus 0.5, which is 2 plus 0.5. And we perform this procedure in the calculator. All you're gonna do is the following. Follow me here, please. We say 3 exponential negative 5 multiplied times sine of 2.15 divided by, I open parentheses and I do this, 2 plus 0.5 close parentheses equal. Did you get the same answer as me?
Yes.
Okay, that's good. Now, the sketch for this problem is slightly different because the angle is not to the bright zone but to the dark zone. That will be the angle here. That will be like the difference.